Good morning, children. Today we'll talk about Ohm's law. Now, what does Ohm's law states? See, the circuit diagram which we are using for verifying Ohm's law is like this. See, what all things are used in the circuit diagram? We have got a resistance. We have got a voltmeter which is connected in parallel. We have an ammeter to measure current. We have a key over here which is used for closing or opening of the circuit, and here we have a source of potential difference which can be changed to verify Ohm's law. Now what does it states? See, it states that physical conditions remaining same. Physical conditions remaining same, whatever current is going to flow in the circuit is seen to be directly proportional to V. That is, V is directly proportional to I. When you'll remove the proportionality sign, you'll get a constant R. This R is known as resistance. V is directly proportional to I, and when I remove the proportionality sign, I'll get a constant which I name as R and is known as resistance. Now physically, what is resistance? See, mathematically now we know it is a constant which will be given by R is equals to V upon I. Physically, resistance is the opposition offered by a conductor or a given wire when electric current flows through it because of potential difference V. More is the potential difference, more will be the current. Less is the potential difference, less is the current. And R will remain constant. This resistance you can, in analogy, understand with, see, whenever any object moves, an opposition is offered. Whenever an object moves, like if you are moving on the way, even if there is no air, if you start moving, or you might have observed when you are moving in a car or in a bus, then air flows in opposition. You are opposed by air. So it's the same thing over here when an electron is moving inside the conductor. This resistance is seen to be dependent upon, number one, length of the conductor. That is L. More is the length of the conductor, more is the opposition. Less is the length, less is the opposition. So R is directly proportional to L. Number two, area of cross section of the wire. That is A. It is seen that R is inversely proportional to A. The third factor which we talk about is material of the wire. And since most of the time material is taken specifically, this does not come in the expression. Number 4 is temperature. Here we'll take temperature as same. We'll be talking about in class 12th how it changes with temperature. So in this in class 10th, we'll not talk about temperature, how the resistance is going to vary with temperature. We'll take mainly these two factors. Alright. And what shall be the unit of resistance? So you can find out from here itself. Unit. What is the unit of potential difference? Volt. Current. Ampere. So the unit of resistance will be volt per ampere, which is known as ohm and is denoted in this form. See, ohm. A straight line with a curve and again a straight line. Alright. Now apart from this, we can directly go to now the one more new constant, resistivity, from this definition itself. See, I've just told you that resistance depends upon length of the conductor, area of cross section. Material is not taken into account in the expression itself. As far as temperature is concerned, we will not talk about temperature in this class. That we'll talk about in class 12th. And that means we are taking temperature same. So physical conditions remaining same, I'm saying. So at a given temperature means R is proportional to L upon A. Again a constant will appear. A constant rho will appear. This is known as resistivity. This is a new constant known as resistivity. And now, how will you define resistivity? Put L is equals to 1, A equals to 1. You'll get rho is equals to R. Resistivity is the resistance when length of the conductor is, or conductor is of unit length, area of cross section is unit square. So resistivity is the resistance of a wire of unit length and unit area of cross section. Alright. That means resistivity is resistance of a specific type of wire or a wire of specific dimensions. Specific dimensions are length is 1, area of cross section 1 meter square, and that is why resistivity is also known as specific resistance. And how will you find out the unit of a specific resistance from here? Unit of rho कैसे निकालेंगे? Rho is equals to R A upon L. R is ohm, A is meter square, L is meter, meter and meter will cancel out. Ohm meter, or you can write it like this. Ohm meter. Alright. And now you can see from here, we had already talked about that resistance depends upon 4 factors. But now you see resistivity, A and L has been fixed. So resistivity will depend only upon these 2 factors. Material of the wire and temperature. So this much you do today. Okay. We'll then talk about this. We'll do some numericals based on this so that you are told specific difference between resistivity and resistance. Thank you.